This video reviews some of the elevator systems and components that are prevalent in forensic investigations. Topics are discussed within the context of legal disputes, including both injuries and financial claims. When looking at elevators from the perspective of litigation, we can simplify most modern systems into three main sections. The machine room, which houses equipment relevant to the power and control of the elevator. The shaft, in industry we call this the hoistway, which is the area of the building where the elevator travels, and the cab, where the passengers ride. We'll take a quick look at each of these categories separately before getting into specific case types. The elevator machine room houses the mechanical equipment that allows an elevator to operate. This includes a controller, which some refer to as the brains of the elevator, a traction machine, which includes a drive machine that propels the system. The machine room also houses the governor, which monitors system speeds within an acceptable range. The elevator machine room is generally located above the hoistway, on the roof of the building, although that is changing with modern equipment. Access to the machine room should be highly restricted to prevent unqualified people from interacting with the equipment or potentially harming themselves. The hoistway will typically extend from the top of the building to an area below the lowest occupied space. This arrangement provides the vertical space necessary for the elevator to service all occupied floors with connections to the machine room on the roof and the pit below grade. Guide rails are installed vertically in the hoistway to guide and direct the course of travel of both the elevator car frame and counterweights. The car frame is a steel structure that the car/cabin rides upon. The car frame includes roller guides, which ride on the rails, the car shiv or dead end hitch, which is where the ropes attach to the elevator, and the elevator safeties, which is what stops the elevator in an overspeed situation. The pit houses buffers for the car and counterweight, which act as a final resort safety feature if either over travel in the hoistway and the other safety measures fail to stop them. There is also a stop switch to allow an elevator mechanic to control the elevator if they need to enter the pit to perform any work. The elevator cab or car sits on the car platform within the hoistway. The cab includes the finished surfaces of the elevator, including the floor, walls, ceiling, and doors. The car sill, which is the component of the elevator that should be floor level with the building when the elevator stops, is also part of the elevator cab. The electrical components of the elevator, including the car operating panel, or COP, that houses the car buttons and display, are powered by wires running from the controller in the machine room to the elevator car through traveling cables. The traveling cables are large groups of wires that provide electrical connection between the elevator and the machine room and travel with the elevator car through the hoistway. The counterweights travel through the hoistway, like the car, but in the opposite direction. If the car is moving up, then the counterweights are moving down. The counterweights offset the weight of the elevator, which helps provide the required traction on the drive shiv of the traction machine while allowing the hoist motor to operate more efficiently. Overspeed incidents are often caused by the failure of the elevator controls system to accurately regulate the speed of the elevator, creating what the industry identifies as an overspeed condition. In cases involving overspeed incidents, investigators may start with the governor, which measures speed to prevent the elevator from exceeding a predetermined upper speed limit. The governor tension shiv in the pit, which is a mechanism to keep the governor cable properly tensioned, may also be involved. The automatic landing system on an elevator controls where the elevator stops at each floor. It is important for the elevator to stop reasonably level with the building floor to reduce trip hazards and provide access for mobility-impaired users. Landing system technology will vary based on the age, type, and the speed of the elevator. The landing technology may include systems that utilize switches or magnets in the hoistway, or selectors in the machine room driven by cables or tapes. The hoistway is sealed off from the public by the hoistway doors, the doors that are visible to passengers outside the elevator. Many people don't consider that the hoistway doors are separate from the doors within the elevator car. When working properly, they open and close in unison at each stop. Hoistway doors are secured using an interlock that mechanically locks the doors from being opened. These interlocks are also electrically monitored by the controller, so the elevator cannot run if the interlock is not fully closed. In a properly operating system, unauthorized users should not have access to the hoistway. In forensic elevator investigations, experts often review service records for the elevator, including maintenance, repairs, inspections, and testing. These service records, along with inspections, can provide insight into the conditions that lead to an incident.